Okay, so first of our 4 talks is going to be given by Michio, and go ahead.
Thanks. I don't know. I'm not quite sure if this is the right place for this kind of narrow-sided, selfish advertisement. But maybe it's maybe this is a place for something that you feel after a week-long discussion or something like that. But I think that the things going on in Japan are something that people have kind of less access to, and while they have a lot of interest. So I hope this is acceptable for you to acceptable for you that I do this kind of advertisement. And I'm sorry for not being very interactive or intercommunicative, but I try to be informative and not too long. Okay. There has been a project on the global change for almost 5 years, which is called Kyousei project. And the Kyousei is a Japanese word whose meaning is something like harmonized coexistence between human and nature and society and so on, or whatever.
Sustainable development.
Yep. Or symbiosis in biology. And it's a national project on the global warming, and started in 2002 and coming to an end next March. And it has several components such as traditional type of global warming projection, but with a high resolution model. This is what Masakimoto has led with Professor Sumi. And this is a development of an Earth system model. This is what I'm doing, working with Professor Taro Matsuno, whose name may sound familiar if you're a meteorologist. And this is, and it also includes components for time slice experiments with a yet higher resolution model with 20 kilometer resolution. So Masakimoto has said that we haven't done climate sensitivity experiment with this resolution, but we did do these experiments as a time slice experiment, prescribing SSD borrowed from a couple of simulations with the Kyousei model. And it also includes the development of a global cloud resolving model. This is not officially a branch of this Kyousei project, but anyway, it's done somewhat under this.
So who's doing the 20-kilometer model?
MRI, Meteorological Research Institute of JMA, Japan Meteorological Agency.
What happens after the 5 years?
We'll touch that topic. And this is what Dr. Kimoto has done with his colleagues. And sorry.
Is the slide shown in Japan?
Yeah, of course. And well, this is just for public relationship, so not for professionals, but it shows the global warming experiment done by our high resolution model with the resolution of T109 for atmosphere and 1/6 by 1/4 for the ocean. And well, as I said, this is mainly for public, so I don't show you this animation until its end, because many of you can imagine the result. The result is anywhere red.
How long is simulation are we looking at? Oh, there's the
Yeah.
years. Okay.
So it's about now, and you can see sometimes El Nino here, although it's too weak.
Is the rain ever asking now?
And the result is, as you can imagine, everywhere red or even white on here. And And okay, so this is our structure of the structure of our system model. It includes a traditional atmospheric model and ocean model and land surface model with ocean biochemistry and land carbon cycle. Aerosol transport model called splinters and chemistry model called Kyousei. This is a tropospheric model. And although we are developing dynamic vegetation model in a narrower sense, we haven't coupled that yet. We haven't coupled that yet. So we have this type of system model and trying to.
So what does Matsuro stand for there?
So this is a land surface model. So a model for energy exchange between land and the air or water exchange or hydrological cycle.
Put together by Matsuda and somebody.
No. This is we are developing this model with NIS, National Institute for Environmental Science, and the Matsuri is the name of the city. NIS is located. Well, not exactly, but many people working for NIS are living in this town. So this.
So you were talking. We're talking about for this kind of short time frame with the higher resolution model.
Yes,
there'd
exactly.
Be simple aerosol and simple chemistry. Like, what level of complexity do you have for your aerosol and chemistry parts?
The aerosol and chemistry parts, it's the same, especially for aerosol part. And aerosol is dynamically calculated even in the higher resolution model that I saw you in the previous slide, but the previous model doesn't have this component yet, and we are not quite sure if we are learning the higher resolution model with chemistry even in the next project. We'll discuss that. Okay, and we are trying to extend the model top to the upper stratosphere or middle mesosphere, which is 80 kilometers or so, including stratospheric chemistry. And for the entire couple system model, we have come up with a nice acronym, which is Kyousei. But some of the members of steering committee of JAMSEC didn't like this name, so we have to keep it as an informal code name. But anyway, we are using this code name. And some of the results under our branch, sort of. And we have done some carbon cycle feedback experiments and obtained results showing significant feedback from climate and carbon cycle interaction. And as I mentioned, we are now separately developing dynamic global vegetation model, which is individual-based model. So trees grown up as a separate individuals in a virtual plot in a grid, and the virtual plots can be multiple in a single grid, if you like. And this is very first result for the global experiment. And this is a potential vegetation, which is observationally based. And this is the very first result from our global simulation. And I think I'm not quite familiar with this field, but I think this result is acceptable, especially for first experiment. Yeah.
The potential vegetation for today's climate?
I don't know.
It's
First,
probably based on Kyousei or something, or one of those formulations. And so when you're saying an individual-based EGVM, you don't spatially explicitly model the individuals, but you have a distribution of plant functional types within a group.
Yeah. So unlike those kind of traditional DGVM, we are trying to model the vegetation dynamics, individual based.
So do you capture age distributions?
Yes, in principle, yes.
So, what did you say the resolution was of this model?
For this model, it's T42. This model. for the atmosphere and for the ocean about 1 degree. And the first branch in which Masakimoto is in charge is also running mid-resolution model, and that is also T42, and we have kind of borrowed that setting from his project. And this is a result from what MRI is doing. I don't know if MRI has slaves, so I don't put that word here. Actually, this is a global experiment, but we have cut off this region. Yes, it's doing something like Katrina, and you can see that tropical cyclones or hurricanes are reproduced in a realistic form. And we have, as I have mentioned, we have performed time slice experiment for the end of this century, and we have from that time slice experiment, we have seen that we will have more stronger hurricanes in a stronger tail for the frequency domain. Although the simulation bears much less number of hurricanes compared to observation, which is shown in black. So this is the end of the century, and this is now.
So this is a global assessment, not just
global, yes.
Okay, good. So could you run that animation again, just for fun?
I don't know if I can help.
It's great. Like two of them form kind of right next to each other out there. They're kind of one's following the other. One shoots up and hits Tallahassee, and the other one is headed for Jacksonville. And the other one died. Yeah.
California.
Yeah.
Yeah.
So perhaps MRI people have picked up most Katrina-like situation, but for the presentation, but it's for the end of this century. And we are also doing global cloud resolving experiment with 3.5 kilometer mesh for the global domain, as shown here. You can see that cumulative clouds are formed in the tropics, while stratus strati are formed in the mid or high latitude regions. And
it's
again,
non-hydrostatic icosahedral atmosphere.
Yeah, so it's
icosahedral grid.
Grid, yes.
What does that look like?
Soccer ball, right?
Yeah, or Fralen, things like that. And so it's one of the modified grids that people are working on across the world. And we have done a aquaplant experiment. So this is without any continent. So it's a very preliminary one, but we have also done plus 2K experiment with this aquaplant model, and calculated feedback effects of clouds, and which has appeared in GRL, Geophysical Research Letters.
So do you get a better MJO with this kind of model?
Yeah. So the situation, how things go eastward or westward, and that kind of thing. That's
better tropical waves. I
think so. At least that is what they insist. Okay. So please note that this is not using any so-called cumulus cloud parameterization or something like that. So the model is forming clouds on its own without parameterization. Of course, you need some sort of parameterization for cloud droplets formation, but not in a sense like Arakawa-Schubert parameterization. And as I mentioned, the project is coming to an end in this fiscal year, Japanese fiscal year, which ends next March. And we have been discussing what form the next project would take over the past 1 year or so, and we have come up this kind of structure for the next project, and after the discussion, and we have submitted some informal document to the minister about 6 months ago, and the structure that we have submitted turned out largely consistent with what we have been discussing over this week. And I don't know, it's not clear at this stage if the whole things are proposed as a single project, or the separated branches are proposed as separated projects. So that's why I have put the brackets here. And but anyway, this is as I mentioned, this is still informal. So it's likely that some modifications will be added to this structure, but it's also at the same time, it's quite unlikely that this structure is totally rejected. So some of the structure will survive, and it includes a projection over 300 years time scale using an alt system type model, and it also includes a 30-year prediction or forecast, if you like, using high resolution models. And it may include socio-economical variables, which may not be directly socio-economic variables, but information for extreme events, rainfall events and hurricanes and typhoons and so on, packed in a way comprehensible for people outside our society. And
by high resolution,
yeah.
What's your what are you targeting?
I don't know. We may be keeping the high resolution model, the resolution for the high resolution model that I have shown in the beginning. It may, it's possible, but we have also planning to extend the model resolution. I don't know which will be the case, but anyway, we have already performed a preliminary experiment using higher resolution atmospheric component, which has a resolution of T213, coupled with a high ocean model with the same resolution that I have shown you. And we are planning to extend the global cloud resolving model so that it includes realistic distribution of continent and realistic dynamics of aerosol and so on.
How long can you run that model, the resolving model?
With 3.5 kilometer mesh, weeks, just weeks, a couple of weeks, and it, well, if you can occupy most of the Earth simulator which we are using, the things are different, but we are sharing the Earth simulator with other communities, so things are not easy. But we are expecting some speed up for the Earth simulator, so it may extend in the next project.
Will you move beyond the aquaplanet configuration to put a land?
Yeah, if this is accepted as it is. And it also includes a branch for reduction or quantification of uncertainties for the global warming projection.
So the comment that tropical waves improved with the cloud resolving model means that the tropical waves were not dependent on any of the continental features since they were the ocean-only version.
Well, yeah, I think so. Yeah. I'm not the expert in this field, so yeah, people say so. Yeah, please.
So what are your plans for this kind of 20-kilometer class of model?
It's included in this category, I think.
So you'd still try to use that in time space?
Yeah. So many of the things are still up in the air. And it also includes a branch for kind of Japan model development. Although it doesn't necessarily mean that we are trying to establish a sort of core model of Japan, but it just says what it's saying is just that we have planned to develop so-called a system of coupler, like ESMF or Prism or Flume or things like that. I confess that this part is the part which is most abstract, which is not specific. So I'm not quite sure if this is really implemented in the next project or not. But anyway, we are planning this. We are discussing this.
If I may make a comment, Masa Komodo in our group
Yeah.
said, this model that you're using for the prediction one, which
Yeah.
has the higher resolution there, some things get better, but some things don't. The ENSOs, for instance, still were 2 years. In fact, the SST errors over the North Pacific of that model are worse than in the lower resolution model. So I just wanted to make a comment that resolution is not a complete panacea for our problems.
Unfortunately.
Yeah, that's true. But the higher resolution is something that you will definitely need for regional prediction. So maybe you need some kind of probability approach using this branch. But anyway, high resolution is
not sufficient.
Yeah, that's true. We know that. We have experienced that. But good news is that, as I mentioned, we have performed preliminary experiment with the T213 atmosphere with the with the same resolution of the ocean, and it reproduces ENSO much better than the higher than the model I have shown in the beginning. So our speculation is that the grid size for the atmosphere and for the ocean should be similar to each other. This is just a speculation that we are discussing, but maybe the case.
So you basically have 3 modeling groups then? You have Frontier, MRI, and University of Tokyo?
And NIS, National Institute.
So there's 4. You have 4 models.
Yeah, 4. Yeah, mainly. Wait. And CREAPI, which is collaborating with ANCA.
Right. But they're not doing model development.
No. And and among those 4 groups, NIS and University of Tokyo and Frontier are working quite closely, collaborating with each other. So, so it's virtually 2 groups.
Okay.
Yeah.
Do the projection model and the prediction model share the same basic physics packages?
Yes, basically.
Parameterizations.
So we are developing a system type model based on thermal.
So right down, right up to T213, they have the same physics.
Yes, basically. And some news about computer resource stuff. And there is a plan to upgrade the altitude, as I mentioned, and we are expecting it more speed up by 4 or 5 times at most. So, and many things are still up in the air, and the budget for this plan is not secured, although it's not unrealistic to have this, to have the budget for this. We are trying to obtain the budget for this. I think it's realistic, but I cannot say anything at this stage. But we have this plan.
So, like among your 4 groups,
Yeah.
about what fraction of the Earth simulator resources do you get for climate work?
For climate work, for atmosphere ocean field, about 25 or 30% is assigned out of the whole computer resource of the Earth simulator, and first more than half is assigned to global warming projection, including Earth system model development. Yeah, I think so.
So for all these climate and Earth system model types of things, you get about 75% of the machine in total.
No, I said about 30% is assigned to atmosphere ocean
And you
field.
said then about half the machine is for
No,
That
half of the 30%. I
half
said.
of the 30%.
Yeah.
Oh, okay.
And there's another plan to develop a petaflops machine. This is maybe after after the AR5 publication, but we. But anyway, there's this kind of plan, and for this plan, the budget is more secure than this, because this is a national project, which ministries are hardly working on, working on very hard. And it is almost admitted that the icosahedral model that I have shown you will be one of the target applications for this machine development. So this is about beyond AR5 stuff. Okay, and things that I have felt after the discussion this week, or some things that I expect to be discussed in the coming WGCM AMS meeting in this September. And the first thing, I'm quite aware that people have deliberately avoided this kind of discussion to avoid any mess or confusion or anything. But I'm sure that groups across the world, including us, have begun at least discussion on this kind of modeling, coupling with socioeconomic models with the climate model through land use change or a carbon emissions scenario or that kind of thing. And this kind of thing should be discussed at least quite soon. And the Earth system model stuff is mainly one of the main themes for AR5, but we remember that the discussion on Earth system modeling has begun well before the publication of AR4, so maybe it's the timing for this kind of discussion, I think. And Kathy has commented that information from fields other than information from fields other than observation should be used for the model development, like Transcom and CFOM, OCMIP and other activities. But Kashi hasn't mentioned paleo community, I think. And so there are activities on parallel climate modeling like PMIP. So I think this should be added for for Kathy's comment, because if you go beyond 2100, there are some phenomena in the paleoclimate which has the same time scale for the time scale beyond 2100, so like Heinrich events or downscale sugar oscillation and some other things. Plus, there are many other things that I don't know. So this is what I felt after the discussion. I'll stop here. Thank you for your attention.